Hi and welcome to today's live stream. I'm super happy that you are here and joining. My name is Mirja and I will be in the chat today. So I will be backstage in a few seconds and leave the stage to Andy, who is also with me in the studio. Hi Andy, what have you planned for today's live stream?
Hello and welcome to today's live stream. We have planned a little, I would say, session about our latest product, Shaper Plate. But before we go to that part, I'd like to mention our autumn deal we have ongoing, which is a free Sustainer 1. You can design yourself, or you can also use designs which are available in Shaper Hub, like this Sustainer inlay for workstation accessories. But as mentioned, it's also possible to get in whatever tools you like to make your own tool case. But that's not everything. You also get this 1/8 of an inch cutter, which is designed to cut brass and which is very useful when you like to build our autumn deal project, which in this case, or this autumn, is the record console project from our US colleagues. And this has a lot of brass cutting in it. So if you want to get familiar to brass cutting, I can really recommend this project. Okay, but now let's go over to plate. And to start, we'll directly cut in a bow tie into this sheet of walnut. And yeah, since we now have plate, it got a lot easier. So I can just place it and use the feet here so that it doesn't wiggle. Then I just place origin on it. With the already designed workspace. So I just have to choose the pocket function for this one. I also have one of our new cutters inserted, so I can go directly to the 80 millimeters depth. It's a 5 millimeter cutter. And because I use plates, I have to do a C-touch. Because I also have to calculate the 6 millimeters of plate in depth. Otherwise, I would be 6 millimeter too high with the cutter. Okay, so let's cut this. For those of you who are not familiar with origin, what you see here on the display is first the green circle, which is the corrective range of my tool. And you can also see the white points inside the circle, which is the exact location of the cutter, of the center of my cutter. And you see, when I go over the design here, over the line of the bow tie, the spindle starts to correct. And it makes sure that I always stay inside the shape and do not cut over it. What you can also see is that it's a little bit offset to the inside. So I can just roughly cut out the pockets and then afterwards clean it up with a nice inside cut. It's 80 millimeters deep, so I have quite some cut forces, and to avoid climb cutting, I'll drive here from the right side to the left side and not the other way around, otherwise I will get into climb cut and the whole spindle will just get pushed out of the way. As you can see, we have the rough pocket, 80 millimeters deep.
Andy, a question
yes.
from the chat directly from Casper, who is asking, okay, which bit is this who can cut 18 millimeter deep in walnut?
I thought that this question will appear. I will show it directly afterwards.
Nice, thanks.
I will just finish up this bow tie with not outside, but with an inside cut. And yeah, because I cut the positive part directly on the line, I will cut this with a really small offset of minus 0.1 millimeters. So this pocket is actually a little bit bigger than my bow tie, and I can make sure this way that it will fit inside the pocket. I hope you can see the correction of the spindle now a little bit better than before, because the spindle will correct all the time. Because now with the inside cut we have a cut line where the cutter always tries to stay on. As you can see, a nice cutout, and let's see if the positive part fits into it. This one I cut on the workstation. Do we have a camera? Top camera?
It's not in the screen.
Oh, okay. But yeah, the workstation is perfect to cut small pieces, which in this case I glued up with some double-sided tape. And as I mentioned, this is cut to with 0 offset, and because the pocket here is 0.1 offset bigger, this now should fit perfectly into the pocket, as you can see here. Very nice. Okay, so before I go over to explain the system, to the question of before, which color I used, I'm not even sure, Mirja, do we already have this in the shop, the 5mm?
Can you show me in detail which you used?
This
no,
one?
this will come in a few weeks.
This one also surprised me. It's an O-flute 5mm cutter with a 30mm cut length and a really big chip groove here in the middle. And yeah, this one can make incredibly deep cuts in pretty hard materials such as oak wood, or as we've seen here, walnut. So yeah, no problem to cut 18mm or even more with this in one go. Cut quality is pretty good. There are cutters with better cut quality, but this one is definitely the best one to do fast cutouts, with also a pretty high quality. Okay, maybe when we quickly have a look at the cutters, here we see the 3mm, 6mm and engraving bit, which come in the basic package. Then we also have the dovetail bit and the T-slot bit here. Then, as mentioned, the 5mm cutter, O-flute. And then for really clean and deep cuts, we have a 8mm free flute and the 16mm also tree flute. 16mm extremely good for fast pocketing, but also very clean cuts. This is on our EU side, and on the US side with a 1/4" shank, we have the following. We have the standard 1/4 inch bit, then 11-degree tapered bit with a small end ball for engraving or cuts which are 5-degree tilted. Then we have a roundover here for rounded edges inside a contour, for example. Then the one which comes with the promo, this one, the 8-inch and 1/4 inch cut depth for aluminum and harder materials. This one is the same, but with a 1/4 inch, sorry, 1/2 inch cut length, which is better for plastics. And this here is designed for foam cutting. Also O-flutes, but with a very long 1.5 inch flute length. Right, these two cutters. But what do we have actually seen before? If you don't know Origin, let me explain you what happened. So we have 3 main parts on the machine. First, we have the camera, which sits in front here, between the 2 LEDs. Here. Then we have the computer in the middle, and we have the spindle here, which the computer can correct within this range here, the circle, which is 1/2 inch in diameter. And the system works like that the camera can see the markers on the workspace in front of the machine. For example, on the plate, we have the tape field here in front. On the workstation, we have pretty much the same, just with the workstation underneath. But it's also possible to do it with shaper tape, with a tape roll. Just glue at least 3 stripes of it onto your workpiece in front of your cut, like this. They don't need to be parallel, just about 10 centimeters of distance in between is everything you need.
Andy, that's actually nice that you pointed out right, because we had exactly this question from Richard in the chat, who was asking, okay, but why do I need plate here? And I answered already in the chat, so you can also do it with tape on rolls, but shaper plate makes you faster. But yeah, let's talk about it in depth.
I'll come to plates later, but first to the general system. Yeah, I'll explain it shortly with the tape here. But yeah, exactly. If you have the tape, it can look like this. You can glue up much bigger workspaces, like meters big, square meters. And when you have glued the tape onto your workspace, onto your surface, you can see that I can't see any movement on the screen, even if I move my Origin on the workpiece. So that just means that Origin has no visibility, no location on the workpiece. So this just means that Origin does not know this particular pattern which is in front of the machine. I quickly can do a new scan to change this. And because the camera is sitting in front and is not movable, I have to move the machine over my workpiece to get different pictures from different angles. And if I press finish, the green button down here, the computer calculates all the photos into one big workspace, which is already done now. And you can see when I move the machine now, the screen also moves, and you can see what's underneath the spindle here. Small point. At the moment it's a part of the dovetail, and down here you can't see anything because we do not have a picture of the scan. because what you see on the screen is the picture of the scan I did previously. Right. That's the easiest possible thing you can have, like just a workspace with 3 lines of tape. But in this case, when you just have like a small cutout, like the bow tie here, I can recommend to use plates because you're much faster. You don't have to glue up your tape because it's already here. And in this case, when I sit origin on it, it's important that I remove the old workspace. Otherwise, the system will get distracted when it can see more or multiple workspaces. So as soon as the machine recognizes a workspace which is already cut, like here, you can see that I see the latest over here, the bow tie, but I can see all visible down here. And you can see I already cut a tactus hinge with this plate. Workspace 247 was something which wasn't that important to name it, but also system 32, another bow tie, and a cabineo hinge. So, Miria, I will quickly mount the other plate onto the workspace here. Do we have questions in the chat already?
Yeah, so there was one question about software for designing, which we recommend. So it's important to know that Origin requires files in SVG format, and SVG stands for scalable vector graphics. So there are a lot of designing softwares which have a direct export with SVG, like Adobe Illustrator, Inkscape, CorelDRAW, Vector, Andy, also Vectorworks, right?
Right, Vectorworks has a plugin which works very nice.
Yeah.
So just draw a 2D plan and export it in SVG, and it's directly
and they are also
available for your machine.
And there are also plugins, as Andy said, but in the future we will also launch Shaper Studio, which is also a simple designed software to create your designs and convert it or load your designs directly to Origin. So this will be your go-to design software in the future, I guess.
We'll have a short look at Shaper Labs later. Our, I would say, the first steps we made in our own CAD, so you can see what what will come with Shaper Labs. Shaper Studio, I want to say. Okay, as you've seen, we can use the middle point of our plate here, and I'll show you how you can actually do this thing here as x-axis and the y-axis in the middle, because this is a really important part of Shaper Plate. If you want to cut a Tactus, for example, or a Cabineo or other hardware with it, it's really important that you know where the 0 point of your plate actually is. So we can do the same here as with the stripes before, with the free one. We do a new scan, make multiple photos of our plate. In this case, press finish. Which needs some seconds. Right, and here you can also see the reticle on the screen, which we will need now to probe the edges. You've seen we came directly to the menu Design from menu Scan after we did a new scan. This happens automatically. And in the Design menu, first thing we do here on Plate is to create a new grid. For this we need the cutter. That's why we have the 5 millimeters here in the diameter. And the thing I have to do now is just lower the cutter until it barely touches the surface of the material. I can set the depth. And now I can push the cutter against 2 points on the radical, on the x-axis in this case. And the third point I can take directly in the middle of the radical. And this gives me the middle point directly on origin, and the same center point I have here on plate with this radical. I also can retract here so I do not cut into it. So I can use this now. For example, if I have a design exactly on this point here, which also needs to be parallel to the axis I've drawn. In this case, I just use plate with a radical, and can put this onto my workpiece like that. Can be sure that this is the center point, actually the same one which I have on the machine. Let's do a small circle of 6 millimeter to make sure that we have the right point. Let's go to 10 millimeter depth. Also use the helix mode. And if I cut this, it should be directly on the center I've drawn. So to come back to the question of before, why to use plate and not just tape? When you have to do one application just one time, then it's basically nearly the same, I would say. But for example, when you have a lot of applications which are centered with a cross, like here, you can use plate over and over again because you have to scan it once, you have to grid it once in the center, and you can put it like on multiple work pieces, and you can be sure that the center point of the radical here is also the center point you have on your origin.
Andy, can I just quickly throw in one question from Tim, who
Sure.
asked, okay, what's the side of origin? Maybe we can show the blue chick here to really
sides,
show, okay, where does origin look at?
When you're in the scan menu, you can actually see like the shape here.
The traverse, is it called in English? Help us.
And the same cut out in acrylics looks like this. So this is the side of origin, and within this base, origin just needs a certain amount of the markers, the shaper tape here. If you're not sure if you have enough of these markers, you have the tape indicator up here, this one. When this field turns gray and later red, this means that the side gets worse. And in this case, when it's red, origin is not able to cut anymore because it has not enough sight and can't locate itself on the workspace. That's why the spindle will retract in this case. So just make sure that you have at least that much sight. Even better when it's completely black, like now. Then you will get the highest accuracy out of your tool. Okay. We've seen the center point of our plate, which to use this one, but for example, when you have hardware, like let's have a look in our freshly made hardware catalog, what we could also do on an edge of the plates. Let's say the Cabineo, for example. When you download this from the Shaper Hub and want to place it on a workspace, it doesn't make that much sense to glue up all the spaces in front of your Cabineo hardwares. It's much better to use plates because in front here you also have the front fence. Here as well with a mark for the center, and here with a x-axis. So you can make a line here on your edge. Can put plates onto this line, retract the fence here, and you're directly ready to cut this Cabineo. In this case, I already did a Cabineo, so I have the workspace somewhere on my machine. And you can see here, it actually sits directly on the point 0, which we have here.
Andy, because this question came up now from Björn and also from Patrick, they are really interested in, okay, how would you probe on workpiece edges? How would you do that, either with plate or without plate? But I don't want to destroy your agenda or your plan, but maybe you can show it.
But that's even better because, we now have 2 indexes, but there are actually 3 different indexes I can use with plate. And the third one are the side flags here. So when you have a look from the top, you can see they flip outside here. And I can use them as side index. In this case, when we, for example, round this edge here, I can also use the front fence, push the side indexes and the front fence against the workpiece, retract this one so we don't cut into it. And yeah, before we probe the edges here, I would say let's also put on a clamp, because this tends to tilt a little bit when the weight of origin sits here in the edge. So in the Sustainer Mini, which comes with plate, you cannot just find the leveling feet like we used before. You can also find these clamps here, which slide in these grooves. And now I can use them to make it stable. So in this case, our center point is not in the middle of plate, it's on the side here. I will quickly adjust or make a new scan so we can see the workpiece underneath the plate at the moment. Like I said before, the picture you can see on the display is the picture from the scan. So from this new scan, you can see the edge of the workpiece we now need at this moment to probe the point 0. So we go back to the grid function create a new grid, still with the 5mm cutter. We lower the cutter so we can probe the side of our workpiece. Like this, 2 times in the X direction and 1 time in the Y direction. And you can see here that points X and Y 0, 0 sits directly on the edge of our material. So directly in the corner, I want to say. For example, if you want to round this corner, we can just create a simple shape on origin directly. For example, a rectangle 200 by 200 millimeters with our corner radius, let's say 45 millimeters. Set this on the corner, so 0, 0. And you can see when we place this and cut this that it will be directly the edge, the rounding we want to have in the edge. So in this case, you see when we have drawn a new shape on origin directly, it's always an inside cut. In this case, we want to use the outside cut. And let's also do 0.5 millimeters offset for the first pass, so we can do a finishing pass later to 0 offset. I'll quickly cut to 10 millimeters. So you can see that it's working. Like you see, we have a nicely rounded edge here with a radius of exactly 45 millimeters. I hope this answers the question about probing in the corner.
Yeah, they were happy. Otherwise, I will let you know then. Andy, just one question. Am I right that you will also later on share, do screen share and show the Shaper Hub hardware catalog, right? And where to submit if someone needs another hardware file, right?
Right.
Okay, so this is then when, yeah, everyone should listen carefully.
Okay, let's directly go to this part. As you've seen before, we now have the printed version of the hardware catalog, where you can find all the hardware we have at the moment on the Shaper Hub. So, quite some pieces of hardware. If you don't find your hardware, the one you're looking for, we also have a simple form where you can submit a piece of hardware you're looking for, and if it really makes sense to cut this with origin, we will contact the supplier of the hardware and work with them to get this hardware as fast as possible onto our Shaper Hub. And how this looks on the internet, I'll show now. So this one was a project, the record console, but with a symbol over here. I can also browse for hardware, which is exactly the same as the printed version. It's a catalog of different pieces of hardware, like Cabineo we've seen before, but also hinges, also bigger hinges, like for example, when we scroll down here, the tactus hinges. How you cut them with plate we will see in a minute. But as I've said before, if you have a piece of hardware you can't find at the moment here in the hardware catalog, you can let us know. Just submit the form down here and we will work on this piece of hardware to bring this into our hardware catalog. Right. So for example, as we have seen before here in the workspaces, there was also one which was called the tactus. And to actually cut a tactus hinge, you normally have the edge of a door. You have to cut this in. And in this case, we can mount it this way with a shaper made vertical fence. And you can see here we used as well the reticle with a center line here to place this accurately on the edge of the door. And yeah, you can fix it with a clamp, cut this hinge, take it to another place and cut the next one. This vertical fence is also on Shaper Hub, because as you've seen before, we do not just have hardware, we also have the projects. And here you find the door mortising jig with all the files you need to cut in the already done SVG files, and some instructions, some material instructions, and the tools you need to build this fence your own. Right, Miriam, are there some questions in the chat?
There is one question, but I think you will talk about it in a second. So it's pointing to the vertical fence of plate. Shall I tell you the question?
Yes, please.
Okay, so Steve is asking, okay, how would you cut a hinge in the door frame?
We do not have the setup to show it, but the first thing I would do is to mark the center of the hinge. So in this case, we made 250 millimeters from the edge. We made a pencil mark like this. Then, as I've said before, we have the reticle here in the middle, which marks our x-axis, and the engraving here in the middle of the reticle. Hope you can see it. Yeah. This one, which marks the center point of the y-axis. So we can just bring this onto our mark. In this case, this way we can adjust it exactly onto the pencil mark. Then use the clamps to fix it. Like this. And if we're lucky, we have enough cable to go over here, which is not the case at the moment. Just let me try it. Maybe it works this way.
Andy, you have to be careful with all the cables of the camera.
Yes. Okay, last attempt. Maybe it works. Very good. So first thing we have to do is to scan the plate. Then, as we've done before, we grid. So set our radical as the center point. So we probe 2 times in X and the third time in the center to get the Y-axis like this. And for sure, we now need to import the files from ShaperHub. We have a special folder for the hardware. When it's Texas 340, we can't find it at the moment, so that means we have to go back to the laptop. Go to the projects, search for hinges, or also use the search bar and type in Texas 340, which is here. Then we just sync it to origin when we are signed in. So I will quickly sign in. Here you can see when you have a symbol over here, that means you're signed in with a certain account. And in this case, we are signed in with the same account also on our origin. So that means when I sync to my files, I should see it seconds later appearing on the origin screen here. And I can use the door part in this case. You can also see that it's designed this way, that we have a small blue line here, which marks the edge of the door. That means in this case, the point here needs to be directly on the edge of the door, and the point of plate which is on the edge of the door is the radical. So we just use the center point to place this blue center point on. That means we have to rotate it 180 degrees and position it on 0, 0, as you can see here. Place it with the green button, and everything is at the point where it needs to be. I hope that answers the question.
Yeah, maybe I understood Steve wrong. He said, I can understand how to cut a hinge in a door. Can you use the tool to curve the door frame to accept the hinge? I'm not quite sure what this means. Do you understand it as a joiner? Is there something I don't get as a non-professional joiner?
I think he's asking about putting plates on the door frame and not on the door itself.
Mm-hmm.
Yeah, depends on the door frame. You can build your own fixtures for plate to make it possible to also do it on the door frame. Always depends on how the door frame looks.
Yeah, you can also work with origin if you are strong enough. You can work with origin on door frames, but we don't recommend it.
On mounted door frames.
On
vertically,
mounted door
you mean.
frames, yeah, vertically.
Okay. Are there other questions? Are we good? Okay. What we've seen is the hardware catalog Shaper Hub, where you can find a lot of files, also for the Sustainer 1, for example, as seen before, but also for things like the vertical fence for plates, but also projects like the double dovetail box you can see here. But what should you do when you want to draw something yourself and you don't have a CAD program, or you have a CAD program which isn't able to export SVG files? In this case, I can highly recommend Shaper Labs, which is our own small software, our own small CAD software, which has some basic functions down here. And you can see this looks pretty familiar, also like the design function on the origin itself. But here we have some more possibilities. We have also like the alignments of the shapes, like this, for example, with the red lines. When you want to place it directly in the middle, for example. And you can use Shapeshifter when you select multiple forms. You can use Shapeshifter to combine these forms and make a new one out of it in a very simple way. Then we also have the text function with a lot of different fonts. On Origin at the moment, in the design menu, we have one font with a single line, but here you have much more possibilities with different fonts, most of them with an outline, not single line fonts. You can place them on your canvas. You can also select all the pieces and, for example, here cut out the word Shaper out of the shape, like this. So in this case, you would be able to cut everything here as a pocket, except the letters. The last function, which is new in Shaper Labs, is the Find Art button, where you can browse for a word, for example, tree. And the program searches for SVGs in a huge library, which are connected to the word. And with just one click, you can bring the files to your canvas. And for sure, you can also combine the new forms. For example, cut out the tree like this, and you already have a new form which you can bring on your origin. Let's call it live stream. And since we're also in the same account as on Shaper Hub and as on the machine, When we save to Shaper Hub, it should appear on our machine in a second. Also, in the import function, on the recent files, you can see that it's already in the Shaper Hub now. You can still scale it up or scale it down. I'll make it 0.5 as big as it is. Can place it on my workpiece. And as you see, at the moment it's an online cut. But I can also select the pocket function and, for example, pocket out all the material around the letters and within the form. Pretty easy. Can also make it an outside cut, inside cut, whatever I want to have here. Very simple and intuitive. Are there any questions in the chat?
There are some questions about Studio, but for this live stream today, we won't talk about Studio in depth because we will have a separate session about Studio as soon as this is released. So for now, we're good.
Most interesting parts about Studio we can already mention is the DXF import. For example, when you have the CAD program without SVG export, you can export DXF, which most CAD programs are capable of, and then import this DXF into Shaper Studio. And there, you're able to convert it into an SVG, which later can be directly imported into your machine. Okay, the last thing we haven't seen yet is the workstation, which is also a fixture kind of similar to Plate, you can say, because we also have the area here in front with the shaper tape. But here in the back end we have some other possibilities than on Plate. Here, like in the example we used for the bow tie, this is the, Miria, please help me, the shelf.
Yeah.
Where you can glue on some small workpieces with double-sided tape, for example. You can also cut out the inline of your workpiece and lay it in here. Like, for example, when we cut the bow tie in here, we can fix it this way and cut something into the bow tie, for example. It's also possible to screw in your workpiece from underneath, but then you have to be very careful to not cut into the screws, because you can see them from the top when you're cutting. This is one possibility. Then the whole thing is much more modular. The two support arms here on the side you can take out to fix bigger workpieces here on the front plate. And you can also set the front plate down. So we have three possibilities. We have the one here where the front plate is on the same surface as the top of our workstation. We have one which is 25 millimeters down, and we have one which is 50 millimeters down from the top of our workstation. So for example, when we want to cut something like dovetails, we can use this position with 25 millimeters and fix the front plate here. we screw out the index pins on one side or on both sides. We fix the support arms like this. Very simple. And we can use, for example, clamps like this, but also the Festool clamps for Festool rails will also work here. Then we have the support bar, which helps for origin to have support in front of the workpiece, but in this case also up here it acts as the point 0 for the height of the workpiece. So I can use the index pins here to adjust it on the side, push it up until it touches the support bar. This way I can clamp it. I can set the support bar back down here. Fix it this way. And as you can see, it's exactly on the same level as the workstation, as the top part of the workstation. And if I put it back quickly at the scan, you can see it on the screen, like here. So absolutely no problem. As before, we can create a grid with probing 2 times in the x-axis, 1 time in the y-axis, and we will have grid for our workpiece and cut it from the top. This to the workstation. Then Miria, do we have questions? Otherwise I will show the System 32 with plate.
Yeah, show the System 32, and also Andy, you were at the US colleagues, at the headquarters in US, why they were also planning their session, because in the chat there was always like, okay, there are different ways of probing with plate, and I'm not sure which versions you showed how to probe, but there is one special version. I think it was Paul and Patrick were really eager to get to know how you can probe with plate, but I was so focused on the chat and answer all these. Do you know which kind of probing they are referring to?
Yes, I guess.
Nice. Maybe we could also talk about that.
I like to do it this way when I have like the x-axis here, but what the US colleagues do, which is I would say the proper way to probe, which is like the way plate was actually meant to probe. We have these things here, the cutouts on the side, where you can probe like this for the x-axis, and the cutout here where you can probe this way for the y-axis, and we also have exactly the center point here in the middle of our plate. Here in front we can use either the fence to probe like this, or as we did before, we can push it against the edge of our workpiece and then directly probe the edge at 2 points. And the center point here we can also probe here. Maybe this was the question.
Patrick is saying yes, and Paul said, thank you, Mirja. I'm not sure if this was about probing, but now I also know which probing type Yeah. So let us know if this answers your question. Okay.
But yes, the two cutouts here on the side and the hole here is for these probing points.
Yeah,
to get
Paul
it exactly.
said thumbs up. That was it. Okay, system 32. I'm a little bit looking at the clock, so let's end this live stream with system 32.
Okay. So the last part, which comes in the Sustainer Mini, which I didn't mention until now, is the small pin for the system 32. It's a 5mm on the bottom, 8mm on the top. And the system 32 works like that we can use the front fence to reference the edge. Then from yesterday, I've already drawn a workspace with system 32 here. It has also the 0 point here in the middle on the front edge, and the circle sits exactly on 37mm. On 37mm from the x-axis, so 37 in y, I would say. And then we have the 32mm steps here for the holes on the right and then on the left side. So we have 5 holes. We'll do a small offset because we have the 5mm cutter inserted for a 5mm hole. We can use the helix function and quickly cut the holes with this one. And in most cases, you need more than 5 holes. So in this case, we need to be able to place plates on another, like on the right or on the left side. And here, the pin comes into play. So we just set plates on this hole here. And because the pin is exactly 5mm, we can use this one to center it and proceed with our system 32 in the next cut window.
Yeah, yesterday in the German live stream, the question came up why this is a longer hole there where you put in the pin. Can you answer this question here also?
Normally you have 37mm from the front because that's exactly where the base plates of the hinges sit. But yeah, the longer hole cutout is also just to be a little bit flexible where you set the holes.
Okay, and Eric was asking for what are the 4 big holes in the upper part on a plate. I was not quite sure if he was asking about where the clamps come in or the flags.
The flags, as shown before, are the side indexes. So I can push them against the workpiece, and I know that I have the side of the workpiece here. And the other 4 cutouts down here are for the clamps.
Okay. So these were all the questions. Yeah. Let's have a look at the clock. So we have to say goodbye, I guess. So thank you very much also for the great chat. It was a pleasure to have all the great questions. And yeah, Andy, any end notes you want to add?
Also, big thank you from my side. I hope it was interesting to see plate. Maybe for the first time, maybe for the second time if you already watched the US session. But yeah, thank you and have a nice evening.
Bye.